Here we are solving some exponential equations that are a little bit more challenging. And what makes them more challenging is the algebraic manipulation that we're going to have to do to solve. So first we're going to take a look at this problem. 8 times 3 to the x equals 5. And when you rewrite it and you say what's happening from left to right out loud or even in your head, you can pretty much figure out what it is that you need to do next. And I said 8 times 3 raised to the x power. So we're going to undo that multiplication and divide both sides by 8. So now we have 3 to the x equals a constant, 5 over 8. And then from here, we can write this in logarithmic form. Log base 3 of 5/8 equals x. And this is called an exact answer. So this is our exact answer. And our approximate answer is going to be, let's think about this. We've got 3, let me move this down a little bit. 3 to the 0 power equals 1. 3 to the first power equals 3. Well, I need 5/8, and 5/8 isn't between 1 and 3. So we're going to have to go backwards. 3 to the negative 1 is 1/3, which is 0.3, which is 3/10. So this is about 3/10, right? About. Well, 5/8 is going to fall in between 1/3 and 1. So our answer, x, is going to be approximately a number between -1 and 0. And this is where we go to our calculator. And we put this into our calculator. And we get approximately, go ahead and try this on your own. And you're going to get a negative number because it's between -1 and 0. So -0 point, ready for it? 3 decimal places, 428. And that's what we call an approximate answer. And on the approximate answers, I usually round to the 3rd decimal place unless it tells me otherwise, which in the homework it just might. So pay attention to how many decimal places you're going to need to go in the homework. Okay, number 6 is a little tricky. So we're going to start with this. If x equals y, then the log of x equals the log of y. We knew that from before, a few problems before this. We also know that we could take the natural log of both sides. The natural log of x equals the natural log of y, as long as we have the same base. Or we could say log base 5 of x equals log base 5 of y. Doesn't matter what the base is. It could be base 10, it could be base e, it could be base 5, it could be base 3. It could be whatever base we want it to be. So in this particular problem, I'm going to pick base 3. This looks like an 8, and I don't want it to look like an 8, so I'm going to erase and make it look like the 3 that it is. Okay, I'm going to take log base 3 of both sides. So log base 3 of 5 raised to the x minus 2 is equal to log base 3 of 3 raised to the 3x plus 2. Now I'm going to take this exponent and I'm going to move it to the front. So x minus 2 times the quantity log base 3 of 5 is equal to, take that exponent, 3x plus 2 times log base 3 of 3. Now log base 3 of 3 is just 1. So all I have on the right hand side is 3x plus 2, because 3x plus 2 times 1 is 3x plus 2. On the left hand side, I need to distribute this number, log base 3 of 5, which is a number that's between 1 and 2. And it's a little bit closer to 1 than it is 2. So we'll say it's like 1.3-ish. You could put it in your calculator and see, but we're not going to put that into our calculator until the very, very end. So we've got log base 3 of 5 that we're going to distribute to both terms in the parentheses. So I've got log base 3 of 5 times x minus 2 log base 3 of 5. And that's going to equal 3x plus 2. Now I have a term with x and a term with x. So I need to collect all the x's on one side of the equation and all of the constants onto the other side of the equation. So I'm going to subtract 3x from both sides. And I'm going to get log base 3 of 5, which is just some number, times x, minus 3x. And I'm going to add 2 log base 3 of 5 to the other side. Now 2 log base 3 of 5 is the same thing as log base 3 of 25. So we could simplify that by making it log base 3 of 25. Here on the left, I'm going to factor out an x, and that's going to leave me log base 3 of 5 minus 3 equals 2 plus log base 3 of 25. To solve for x, we're going to divide both sides by this binomial log base 3 of 5 minus 3, log base 3 of 5 minus 3. And our answer is x equals 2 plus log base 3 of 25 over log base 3 of 5 minus 3. This is an exact answer. Now, why did I go with log base 3? Because this coefficient was 3x. So I figured that if I did log base 3 of 3 to both sides, I would just have that 3x by itself. And then I'd be multiplying this x by log base 3 of 5. But it really doesn't matter whether or not you do log base 3 of both sides or log base 5 of both sides. So that's our exact answer. Our approximate answer, when we put this into our calculator, is negative 3 point. You can go ahead and try this if you want. So press pause because I'm going to give you the next 3 values, or in the decimal, 2.12 or 0.212. So negative 3.212. This is the approximate answer. So this is your approximate, and here's your exact answer. And in the homework, you are going to have to do both the exact and the approximate. Using your calculator is important, but being able to manipulate the algebra and come up with an exact answer is the skill that's going to help you when you move on to the next level of math. And that brings us right into factoring. Factoring is a skill that is so incredibly crucial, and it just keeps popping up over and over and over again. Now remember, quadratic in nature, we talked about this before. Quadratic in nature is when the first exponent is twice 2 times the second exponent. Okay, so we've got the first exponent is 2 times the second exponent. So let's see if we can't manipulate this equation so that we can make a little bit more sense of it. When you're used to seeing those exponents on those exponent quizzes that we talked about in the past, you see 4 as 2 squared. So I've got 2 squared raised to the x power minus 2 to the x minus 12 equals 0. I'm going to use my power to a power rule. 2 to the 2x minus 2 to the x minus 12 equals 0. And then we're going to factor this into 2 binomials. Now, how do I get back to 2 to the 2x? Well, that's going to be 2 to the x, 2 to the x. this is tricky. 2 to the x times 2 to the x. You keep the base and you add the exponents. X plus x is 2x. You keep that base and you just add the exponents. So that's how we get back to 2 raised to the 2x. How do we get back to negative 12? Well, we've got 6 and 2, and we've got 4 and 3, and we've got 4 and 3. That's going to work. So this is how it works. So let me show you. And this, you know what, I'm thinking better of this because I'm thinking that this is going to, I'm going to continue with this. Minus 4 plus 3. But I'm going to show you another way. So I've got minus 4 times 2 to the x plus 3 times 2 to the x. Well, that's going to be negative 1 times 2 to the x. Let me show you. Negative 4, 2 to the x plus 3, whoopsie. Negative 4 times 2 to the x plus 3 times 2 to the x. Well, when you add like terms, it seems a little weird right here, but you factor out negative 4 plus 3, that's negative 1. So 2 to the x times negative 1 is negative 1 times 2 to the x, which is negative 2 to the x. So if you followed that, you're good, right? If you didn't follow it, we're going to make this a little bit easier for you. So it is important for those people who can follow this, not what I'm doing right now, but people who can follow this to be able to do that. So you're good to go. But people who can't, which don't feel bad if you can't, it is challenging to wrap your head around it, especially if factoring isn't your thing. You can get better at it, but we just have to practice. So what we're going to do is we're going to do this thing called U substitution. So I'm going to pretend that I've got U squared. So let's even take this a step backwards and say, okay, 2 to the 2x, watch this, is going to be 2 to the x squared. 2 to the x squared. Same thing, right? 2 times x. 2 times x is the same thing as x times 2. So I'm just going to reverse those, and that is absolutely something that I'm allowed to do. And now I'm going to go off to the side and say let u equal 2 to the x. So now I'm going to have u squared minus u minus 12 equals 0. And u squared minus u minus 12 factors to be u minus 4, u plus 3 equals 0, u equals 4, and u equals negative 3. But remember that u is 2 to the x. So 2 to the x equals 4, 2 to the x equals negative 3. First one is easy, right? 2 to what power? 2 to what power is 4? Well, 2 to the x is 2 squared. That means x equals 2. You probably did that without even doing that middle step, which you're good. So x equals 2. That's one of our solutions. Now we have to come over here and we have to say, what number can I raise 2 to and get negative 3? So what number can we raise the base of 2 and then have a result of a negative number? Well, if I put negative numbers in, negative numbers are going to give me fractions. 1 over 2, 1 over 4, 1 over 8, 1 over big numbers, not 0, and definitely not negative. Therefore, this produces no solution. And if you think about the graph of 2 to the x, you've graphed this hopefully enough. The graph of 2 to the x looks just like that. There are no outputs. This is your x-axis and this is your y-axis. There is no value of x that you can put in and get a negative 3 out. It's just not going to happen. There's no solution. So our only solution is x equals 2. But it is a solution. If you put 2 in, 4 squared is 16, minus 2 squared is 4, 16 minus 4 is 12, 12 minus 12 is 0. It works. Now what can we do here? 4 raised to the x plus 3 equals 25 times 4 to the x. And I think that there's a typo here. I think this is supposed to be a 2x plus 3. 4 raised to the 2x plus 3. So let's make it that. So 4 raised to the 2x plus 3. Well, what if we divided both sides by 4 to the x? Could that do anything for us? Well, remember our quotient rule. If we have a to the m over a to the n, you keep the base and subtract the exponents. So that's going to get us somewhere. So we're going to keep the base of 4, and we're going to have 2x plus 3 in the numerator minus x. And that's going to equal 25. And now you can probably see why that was supposed to be a 2x plus 3. So simplifying, 2x minus x is x. So now I get 4 raised to the x plus 3 equals 25. I can write this in log form. Log base 4 of 25 equals x plus 3. I'm going to subtract 3 from both sides. Log base 4 of 25 minus 3 equals x. Now it's important that you write the 25 in parentheses, especially if you're going to put the negative 3 at the end. This is our exact answer. That is indeed our exact answer. And our approximate answer, x is approximately going to have to go over to my calculator to do this. So I'm going to put this into the calculator. Log base 4 of 25, that's going to be between 2 and 3, closer to 2. So I should get a negative number. So this is going to be 2 something, I'm going to say this is like 2.2-ish, maybe 2.3-ish, minus 3. I'm going to guess, this is a guess, I'm going to guess negative 0.7. Okay. Really important for you to be able to start looking at these expressions, these numerical expressions, and estimating them. So if you're still having trouble with that, 4 squared is 16. 4 cubed is 64. I need 25. So 4 raised to some power is 25. It's going to be between 2 and 3, and it's going to be closer to 2 than it is to 3. So that's why I guess 2.3. I'm going to put it into my calculator right now, and I'm going to put it in there because I'm kind of curious. It was a complete guess. 2.3, 2.322, 2.322. Look at that. It was really a complete guess. I'm going to take that 2.322. I'm going to subtract 3, and I get negative 0.678, and that's an approximate answer. So that indeed is our approximate answer. And I think we have one more problem left, maybe for you to try if you like. You're going to need to be able to kind of work through these things. Think about what you might do. What might you do to solve this? And then come back and join me. Okay, so what I'm thinking here is saying, let's get everything over to one side. So 3 to the x plus 2 plus 3 to the negative x. And that's going to take care of one of our negative values. Sometimes we don't like those negative values. Then I'm going to say, okay, let's make that exponent positive because we don't like negative values, right? No. Who likes negative values? So we make that 1 over 3 to the x. Then I'm going to multiply every term by by 3 to the x. So 3 to the x times 3 to the x, well, that's going to give me 3 to the 2x. Plus 2 times 3 to the x. Oh, this is looking pretty good right now. We've got the first exponent is twice the second with the same base, plus 3 to the x times 1 over 3 to the x is 1. So I've got 3 to the x squared plus 2 times 3 to the x plus 1 equals 0. If we let u equal 3 to the x, then I'm going to have u squared plus 2u plus 1 equals 0. That's u plus 1 times u plus 1. U equals negative 1, which means 3 to the x equals negative 1. And 3 to the x will never equal negative 1. That's just not possible. Therefore, that's what the 3 dots means. Therefore, there's no solution. No solution. So different types of problems, different levels of challenge with solving equations. Therefore, as you work through your homework, you should find the worked out solutions to be somewhat helpful. If they're not helpful, feel free to, ask. Don't give up. Persevere. Ask the questions, even when you feel like they are simple. Do not be afraid to try something and then to learn from your mishaps.